Okay, welcome everyone to lesson 12. Here we are with almost our final lesson, but I would rather say this is actually the final one because the next one is kind of a I don't know, it's a more relaxed topic, but this actually has really important things to go through. So um, basically optimization, performance, and finalizing a project. So in game development, as you may imagine, as you create a game, there are just going to be a lot of systems, right? A lot of code, and those systems have to work together, right? So if I shoot someone, if I shoot an enemy, the um, something somehow has to handle uh, that event. For example, if it's a multiplayer game, right? That also has to be forwarded to every other player if we want to display that to them. Or if we want to start a dialogue, the so-called dialogue manager has to know about it, and then we'll have to display the dialogue on the UI, right? All these things. So it's important to bear refactoring and optimization in mind, and to frequently perform um, kind of code reviews. I don't like to call them like that, but yeah, sometimes you just have to revisit your old code, and also documentation is pretty important. Partially for this and partially because if someone else has to work with the code that you wrote, if you have documentation, they will at least know what they're working with instead of having to like instead of having to interpret the code themselves. And another important thing that's kind of like it goes hand in hand with optimization, and that's like assessing performance. So if I launch the game now, we can actually look at our game's consumption of resources. Well, of course, you can do it from the task manager, sure, but here it's just much easier for us to go to the debugger and then profiler, and if we hit start, this gives us a breakdown of all the code that we have. Of course, if we had more things, this would be more filled. But for example, you can see that the frame time is like 16 milliseconds, and that is because we are capped to 60 FPS. Do you remember how we said that physics process is tied to a frame rate? Now, if we divide 1 by 60, we're gonna get this value. Of course, we need to do that, multiply by 1000, but yeah, this is just kind of proof that physics is actually tied to 60 FPS. And we can also look at particular frames of the assessment, right? And this gives us a better idea of what's going on. So, for example, we can see that kind of rise in frame time, and we can just go there and see what's up. Obviously, it's just like nothing that has to do with our code in particular, but there may be some spikes if you're actually profiling a game that has like a bunch of different function calls. You can also see our process here, and if you just had multiple functions, they would all be broken down here. And that's insane useful to see how our performance is. We can also check the VRAM. Of course, we are not using any, but I've been in projects where like 2 gigabytes of it have to be consumed, and then there's also that to optimize. So yeah, this little tab for benchmarking is really important. And now that I mentioned VRAM, actually another common thing in games is like as something is off screen, right? So if you assume that if I launch the game, sorry, this level. Oh, okay. This is just my stuff. Sorry. Let's see. Yeah, if I launch. Oh, this is actually from a previous lesson. Okay, anyways. If I launch the level, now in the profiler, if we store it, you're gonna see now we have several different things here. And for example, for the path that we've created, the pathfill 2D, it also has its own process call, right? At this point we can just delete it. And now it's gone. So, oh, yeah, right. Why are these notes here? I don't think we have covered this. Maybe it was just me messing around with them. But okay. Anyway, so if you have this level and for example this sprite, oh yeah, we can't move that one. If this guy moves out of bounds, we don't want to render them. And for that we can use the visible on screen notifier and the visible on screen enabler nodes, which deal with the, well, visible on screen enabler deals with like actually enabling or disabling the particular node that we like place this on. And this can save performance actually, right, in the grand scheme of things, but in like smaller projects it doesn't quite matter. Okay, so when we've created the game, we also need to make a build of it, right, so that it's actually playable. And to do that, if we go into the project tab and go to the export option, we will need to add a preset. So these are just the destination platforms, right? We could say Windows desktop, and if we set the export path, right, I'm just gonna tab out, new folder, Godot builds, and I'll call it game.exe. Now we can export it. I'm gonna say we export the debug build, and this just builds the thing. You may need to actually download a export template, but Godot will just prompt you to do that, and the download is automatic, so you don't have to worry about that one. Okay, now we got our game exported, and it's just the default scene, right? The one that we've assigned. It's is it that one? Let's see. Yeah, it's this one. We just set the text to to something different, right? Oh yeah, right, here, the label text, okay. So yeah, that's how we export the game. And to like debug it, right? Because we can actually, do you remember how some games have these debug consoles and also certain debug keybinds, like a God mode and stuff like that. So we can actually launch. Here's like the, yeah, before that here's also the console of the game. So whatever was printed in the editor output here, now if we launch the game.console.exe, that's gonna get printed here. So this is also useful for debugging. And then if we type cmd into the file path, right, or our exe's directory, then we can also launch the game ourselves here by typing the exe name, and we'll still get the console prints. However, and you can stop the process with Ctrl C. However, we can also append several arguments to launch our game. So for example, I could say I'm gonna launch it with debug or something like that. And then now you can see this is actually built in for Godot. So like launching with the debug argument will also show us these little things, these kind of errors. We also have print debug as a function. And yeah, I think this will also just only print in the console when we run with the debug argument. And we can also check what arguments the executable has with os.get cmd args, yeah. So if I just print this, now of course if I were to launch the game here again, this would not do anything, right? But if I launch it here, this will give us an array, and basically here the argument is just like the scene that we have. We can also assign things, right? And here's a little boilerplate for like parsing argument values. And there's also in the OS global class still there's a function called hasFeature, and this is important, for example, to determine whether like your build is also from the editor or not, or if it's a debug build. We can also refer to the feature text page for details, right? This is where you are running an editor build or a debug build, and yeah, there are just a bunch of things here too. And I think that's it for finalizing your project. Actually, the exe also comes with a pck file that you will want to keep besides your exes, or you want to keep it in your exes directory, but also right, also it's important to, like, when everything is done, it's important to ship the release build, obviously. So that's it for this lesson, and I'll see you around for the next one.